Hi, hello. So I thought I'd just share with you a project which I put on Instructables about how to make a flat pack 3D printer enclosure. Now, I guess as you're looking at this video, you're obviously just not looking for a standard static enclosure. Maybe you end up going to trade shows, maybe you go to maker fairs, maybe you're like myself, someone who ends up using their 3D printers in all sorts of different locations as a design professional. Or it could be that you just haven't got the space for something really, really bulky and you need it to collapse down. So I actually still have it with me, and what's been great is that it is kind of one of those nice things where I've been using it for quite some time and it's working out really, really well. And obviously this goes to the full size, and of course we have the lid as well. So what's great, if you haven't come across this website before called Instructables, do go check it out. There's links here and in the bottom. And what's really good about it is that it breaks everything down into little steps. And generally most people are good at putting links for where you can source all sorts of materials like this stuff, which is polycarbonate, essentially fluting. If you can see that there, 2 layers. And it's basically like corrugated card, but if made out of polycarbonate, which is much, much stronger and able to resist, reasonably high temperatures. And certainly most 3D printer enclosures aren't even going to get close to the above 100 degrees, melting points of these sorts of things. So it's really quite a nice lightweight thing to use. And I guess the little trick was using, as you can see, these piano hinges to make it all come together. And as you see, it just folds away nicely. And there's the printer. So again, not sponsored. This is my own printer. In fact, ironically, I won this printer from entering an Instructables contest. So I'd also advise you to do that and take a look at it. A whole bunch of stuff on how I ended up doing this on the website. But basically, I also wanted to share in this video just a few tips and tricks. If you're considering doing this project, what sort of things are nice little design shortcuts. So sometimes you're in a situation where you think, right, I need to take a careful reference of points and transfer them onto something else. And so one of those examples was these feet I wanted to work out, and they're not actually all in exactly the same square space. So a good trip is to throw down a little bit of ink from this permanent marker and then basically squash it onto the MDF board. And that allowed me to take a quick reference, draw around them, and then I printed some little sockets so that it wouldn't wobble around and change its place. Because MDF's actually quite smooth, as I'm sure you're aware. So anyway, this stuff, as I mentioned, really cheap and easy to cut. We're talking for a sheet that could do this whole enclosure. It was probably no more than about maybe $15. So sort of roughly £12 or something like that. And again, that was with some offcuts as well. And the piano hinges were basically about $1 a pound each. So again, cutting them into size. I then used a nice little trick of taping them with sellotape into place. And obviously the nice thing is it makes you sort of just double check that you've got the folding going in the right direction. It's a very easy mistake to make before you apply the glue. And then scrolling all the way through, we can see that this is just some little tricks on how to apply epoxy. I used very, very fast stuff, which was 90 seconds. But, if you have a bit more time, go with the maybe the 5-minute stuff, as you just get that little bit more time to wiggle things about if it's not quite right, if you're new to epoxies. So again, applying it with the sellotape holding it in place. You can see one of the really great benefits of this is that it holds it so that you can open the hinge, apply glue behind it, then squish it shut again. So there we go. Once you've got a reasonably good bit of adhesion and you can feel on the little pad of glue here that it's starting to get tacky, that's a good time to make sure you've given everything a clean down before it gets too tacky. And again, just checking the line up and checking the spacing here. And then what's great is if you leave it so that the glue actually starts to become really quite almost set, this is a really good way of fixing the mistakes, because it turns out if some of it has splurged out onto the hinge itself, you basically just grab a little bit of cocktail stick or a bit of wood and basically just almost fidget around with it and it will ball up. A little bit like if you ever tried to remove blue tack off a wall, it's easier to use the blue tack itself. So once you've got a little ball of this, it actually is easy to clean the rest of it once you've done that. And so there you go, the finished result, nice and clean. So again, peeling off the tape once it's actually had time to properly glue. And again, you can see it almost leaves these nice little sort of riveted sockets, which even more help key the thing into place. So there we go, that's the final thing, and there's like 3 stages there. And obviously the 4th one's a little bit the tricky one, where you have to bring it together with a little bit more care. And then check before it's completely set, that last one, that everything collapses and opens nicely. So as you can see, the sides to the wooden base that I wanted to make, I didn't want it so that the thing slipped off it. And so I basically just put a little bit of ABF. And again, I've got a website down here, Design Modeling, which shows a whole load of tips on how to work with things like sheet plastic. But again, a really classic tip is using essentially a craft knife or a scalpel to score it and then snap it over the edge of a table. And you can even pull it against itself in the opposite direction, as shown here. And that's a really good way to just sort of model very, very quickly without having to necessarily have a bandsaw to chop it up. So again, small things. I could have put something fancy like glands on it, but in the end, all I did was just cut a little slot and let the wires creep through. And there's nothing really here that becomes razor sharp that I think it would be concerning to cut through a high voltage cable. And indeed, the side of the cable that is on this side of the adapter isn't very high voltage anyway. So even if we were to be very safety conscious. So essentially the door I think is a nice little touch, as you know, I'm sure everyone doesn't want to always lift off the enclosure every time you just want to put the bed back in or take the parts out. And of course the benefit is it keeps the heat in inside as well. So this door, I think you can see from the guide, but it's got a little bit of a knack, which is using these magnets. You can see right here, these little fellas. And I've just basically squished them inside the fluting, which is the void here, just with a little spudger. And again, I've just sort of done the same with the lid, basically making it so that it fits with a little bit of tolerance. So again, it's great that it basically collapses. I've used it quite a few times and it's allowed me to go to places and not worry about the fumes getting out of control. But again, I think a nice little addition to this would be even putting in a 100mm 4-inch hole, and I could actually duct it to outside if I needed to. As it happens, my workshop has windows in it, so it's not a problem. But I think that would be a really great fix for future, or indeed, if you have any tips, please post them below. I'd love to see how it all worked out for you. And again, sharing any other things and ideas or requests. Thanks again. Bye.